So now we're going to talk about the concept of differentials. If y equals f of x, then we say that dy is equal to f prime of x dx. This symbol dy and this symbol dx are differentials. Before we talked about dy over dx. Now we've taken the dy and the dx and we're not writing them as ratios anymore. And in this setting, the dy and the dx are called differentials. Let's look at an example first and then talk a little bit more about what dy and dx means. Example is find dy if y equals x squared plus 3x minus 2. Examples like this are not all that much harder than finding derivatives. You just have to remember to use this formula. Well, we need y equals f of x, so we need to identify what f of x is. F of x is x squared plus 3x minus 2. And to use this formula, we just need the derivative. F prime of x is 2x plus 3. Simple enough to take the derivative. So now we just take this 2x plus 3 and we put it in this formula. And that says dy is equal to 2x plus 3 times dx. Notice that we have to have parentheses around the 2x plus 3. Dx needs to be multiplied by this whole thing. That's the answer. Dy is just equal to 2x plus 3 times dx. It's very important that you have a dx there. So when you write dy, you don't want to just write dy equals 2x plus 3. You need to write dy equals 2x plus 3 times dx to get it right. And that's because there's this rule that differentials must balance. If you write a dy on this side of the equation, there has to be a dx on this side of the equation for this expression to make sense. And so we have to essentially have this form, dy is equal to something times dx. And if you do that, if you remember to do that dy is equal to this something, don't forget to put in the dx, you'll get it right. So let's talk a little bit about what the dy and the dx really are, and why we say they must balance. Well, dy and dx we can think of as intuitively as infinitesimally small quantities. And what we're saying is if we have an infinitesimally small quantity, an arbitrarily small, tiny, arbitrarily infinitesimally small quantity on this side, this equation only makes sense if we have another infinitesimally small quantity, dx, on this side. So we say dy, this infinitesimally small quantity, is equal to this scalar times dx times this infinitesimally small quantity. So this is an equation about infinitesimals. We're saying for y equals f of x, an infinitesimal change dy is related to an infinitesimal change dx by multiplying dx by the derivative 2x plus 3. Now, infinitesimally small quantities are different kinds of animals than just ordinary things like 2x plus 3. To define them rigorously mathematically is a little bit beyond the scope of what we're going to do in this calculus course. But all you really have to remember about them is think of them as infinitesimals, and that when you write dy on one side, you have to have dx on the other side, and you'll be able to use differentials. We're going to use differentials a lot when we get to integration, so you need to remember this notation and how to use differentials.